All right. I won't start just yet. I'll wait another 2 minutes or so. But if you would like to kind of try and start these without help and without watching me do it, this is in on campus. It's under Chapter 2 material, and it's the practice test labeled with like a parentheses. Um, looks like that, right? So it says Chapter 2 practice test or something along those lines, and then it has a 3 in parentheses. That's the one we're going to be using. Um, and then all of this on here, that's pretty much everything we've covered. All right, in a really, really, really tiny nutshell. Any of the completing the square problems on the test where a is greater than 1 can be simplified before doing the box method, right? You have to factor out the a, which that's like one of the first things we're going to do. So, well, it's the third thing we're going to do. So just hold on a second and we'll go over an example. Also, before I start, this is going to be a little bit different. So I'm doing this live for juniors that are taking the test tomorrow. And then for seniors who are taking the test next week, this will be available so you can watch it whenever you want. So take a look at this in like the next minute or so. I'll start as I usually do, and we'll go from there. Okay. So just as a quick recap, um, I'll go in and get started. It's 7:35. So this test, obviously, chapter 2, quadratics, higher order polynomials, and rational functions. Oh, that doesn't sound good. There we go. Okay. Um, so three kind of like major topics in this chapter. There's quadratics, which you all should know how to do. That's all from algebra 2. It has to do with finding zeros either by factoring, quadratic formula, or square roots. Yes, you have to know the quadratic formula. Okay. And then besides that, we worked on converting to two vertex form, which we saw a lot in the first chapter with transformations. So when we do that, we're doing what's called completing the square. And then we also, from that, should be able to label the vertex, which again, we did last chapter. You guys just didn't call it a vertex. Then we talked about higher order polynomials. So really, our only goal for those is to be able to graph them and kind of work with them using the same ideas that we did with quadratics, right? So we should be able to find zeros. We should be able to use the leading coefficient test, and we should be able to use the intermediate value theorem, right? So our goal is to graph them, but we have to do other stuff in order to do that. From both of those things, we need to be able to work with radicals, and specifically, we need to be able to rationalize them, possibly with complex numbers. So that complex number, that's that I down here, okay? And then the last topic was rational functions, which is what we just finished doing. That is finding the vertical, horizontal, and slant asymptotes, and then graphing them using the intermediate value theorem and long division if we need to. Okay, so all of this here, that's what we've worked on the last like month or so. Okay, so leading coefficient test, that's up there in blue. A lot of people have asked to see that again and again. It's literally just that, right? So even degree, odd degree, and then positive and negative leading coefficient. Okay, so those are what those general shapes are going to look like. The asymptotes, I copied that down from memory, and I think that's all right. Um, that's how that's going to work. I'm not going to read all that because you guys have seen that all the time. That should be in your notes. And then the conjugate, which is what we're going to have to deal with when we're rationalizing, and then what I actually is. Okay, so this is like I said before, this is all of what we've done in a really tiny nutshell. Okay, so what I'm going to do, I'm going to just, as I normally do, go through the tests. As you have questions, just ask. I'll keep an eye on the content, comments, and I'll try and keep an eye on my email. Um, so yeah, we'll just go on from there. Okay, so again, this is in On Campus. It's that newest download. There's one thing I changed, and that's number 4. I printed this to a PDF before I caught this. Everything else looks good, but this one is a little bit different. So we're going to go with the equation I have in blue. But we'll cross that bridge. So first 2 problems. Find and label the vertex by completing the square. So when we're completing the square, we're really only worried about these first 2 terms, and we're trying to make a perfect square out of those terms. Okay, so if we make a box, put k squared up top left, factors of k squared are k and k. Right, so if the area is k squared, we know each of the dimensions have to be k. Okay, then we have to split up this negative 8k evenly in between these 2 boxes. Right, so negative 4k and negative 4k. Which means that this dimension must be negative 4 and this dimension must be negative 4. Okay, so what we have are we have the dimensions of this box. That's k minus 4 times k minus 4. And the only thing we're missing is this area down here, which is negative 4 times negative 4, which is positive 16. Okay, so if we put this back in, we get k minus 4 squared. And then minus 7 is equal to 2. But on the left-hand side, we added this 16 that wasn't originally there. So we have to add that 16 on the right-hand side too. And then all we have to do is get everything to the left and label the vertex. So we get k minus 4 squared. 2 and 16, that's 18. Negative 7 minus 18. Negative 25. I think that's right. And then this is our equation in vertex form, and our vertex is 4, negative 25. Okay, so that's essentially how you complete the square. Number 2 is a little bit more complicated. Everything is pretty much the same except for the first and last step. Again, we're still only worried about these first 2 terms. But when we look at vertex form, right, there's no coefficient in front of x inside the parentheses. Okay, so we need to make that happen for our set of parentheses too. So we have to factor 5 out from both of these terms inside this box. So we get 5 times k squared minus 2k minus 50 equals negative 3, right? So everything else is the same. And then we just do the same thing for this stuff inside parentheses. So we get 5 times this box now. Minus 50 is equal to negative 3. Okay, and in this box, get k squared up top left, so k and k. These 2 like corner boxes, caddy corner boxes, those have to add up evenly to negative 2k. So that means negative 1k goes in this box and negative 1k goes in this box. Which means this dimension is negative 1 and same with this one. Okay, so everything we have now is exactly what you see above that step I wrote. So this one and the one above. Everything is equal. Okay, but we have this missing box in the bottom right. Okay, so what would be in that box is negative 1 times negative 1, which is just positive 1. Okay, but that positive 1 is inside that set of parentheses. So we didn't just add 1 to the left-hand side. We added 5 times 1 to the left-hand side. So in order to even that out, we have to add 5 to the right-hand side. So if we write that out kind of neatly, the area of this box is k minus 1 squared with 5 out front. And then we added 5 to the right-hand side because we added 5 to the left-hand side. Then we get everything to the left, and we have our function in vertex form. So negative 3 plus 5, that's positive 2. Subtract 2 over, so minus 52. So this is our equation in vertex form. And then our vertex is 1 comma negative 52. Okay, so I want to make sure people understand that. So look at that for a second, make sure you don't have questions, and then we'll go on from there. All right. So from there, we go to number 3. Number 3 just says to solve each equation using the quadratic formula. And then if the zeros are complex numbers, just simplify it. Okay. And again, this one probably wasn't that great. But our quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we just identify a, b, and c, and then plug it into that formula and simplify. So a in this case is 10, b is 0, right, because we have 10v squared plus 0v minus 15, and then c is negative 15. So then we get x is equal to negative b, so negative 0, plus or minus the square root of b squared minus 4 times a times c all over 2a, which is 20. And then all we have to do is simplify. Right, so we get x is equal to plus or minus 600. I'll check that. Yep. Okay. So we have x is equal to plus or minus 600 all over 20. And then our job is to simplify this thing in the square root, or the square root. How often, like on the test, will either a, b, or c be 0? I should have looked this one over too. There should be a b in there, but it could happen. I'm not saying it won't, but I'd like b to be in there. It's still the same process. There's just a 0 thrown in. Okay, so now we need perfect square factors of 600. So I haven't looked at this, so give me 1 second. 600. I know we can take a 25 out. 25 into 100 is 4, and then times 6, so that's 24. Yeah. Okay, so we can rewrite square root of 600 as square root of 25 times square root of 24. Square root of 25 is just 5. So we have 5 rad 24. And then we can simplify rad 24. So we get 5 rad 4 rad 6. Rad 4 is just 2. So we have 5 times 2 times rad 6. So we have 10 rad 6. Okay, so our actual answer is plus or minus 10 rad 6 over 20. And then you can keep it like that. If you want to simplify, you can. So if you simplify this, this would be plus or minus 5 rad 6 over 10. No, we can do better than that. 2 over 4. And then 1/2. I don't know why I just didn't go there to begin with. Right, so 1 rad 6 over 2. Any way you could show work for this one? 9x squared plus 4x plus 4 is equal to 0. Yeah, I can do that real quick. I will do that. Oh yeah, I mean that's. Oh no, that's okay. That's from the practice test that I gave you in class. 9x squared plus 4x plus 4. So this is one that I gave you guys. So if we use the quadratic formula, a is 9, b is 4, c is 4. So we get negative 4 plus or minus the square root of b squared, so 16, minus 4 times a times c, which is 4, all over 2a, which is 18. Okay, and if you simplify this, you should get negative 4 plus or minus the square root of negative 128 over 18. And this is, keep in mind, this is just a different example. So don't get confused with this in white with that in red. Okay, and our job would be to simplify this thing as much as we can. Okay, so we need to look at square root of negative 128 because everything else is pretty simple. So square root of negative 128, we need to pull out perfect square factors, and then we need to deal with this negative. So we can rewrite this as the square root of negative 1, and then perfect square factors of 128. 2 goes in there and 64 times, so square root of 64, square root of 2. Right, so 2 times 64 times negative 1 gives you 128. That's why we can do this. Okay, and then we just simplify as much as we can, right? So square root of negative 1 is I, square root of 64 is 8, and then square root of 2 just stays there because we can't, there's no perfect square factors of 2. So then we would just substitute what this is actually equal to. So we'd have negative 4 plus or minus all of this, so 8i rad 2 over 18. And you could simplify from there, but if you get here, you'd get full credit. So you do, yeah. Okay, so I'm getting a bunch of error messages on my computer. Hold on. Okay. This is how I would want your answer. Okay, your job is to simplify this square root of a negative and then this square root of 128. Just because the answer is complex, it doesn't really do anything. It's just another factor that you can pull out. Okay, so negative 4 plus or minus 8i rad 2 over 18, that's what I'm looking for. That is perfect. Okay, so long as you don't have an I in the denominator, you don't have to do anything after that. Okay, so I'm hoping quadratic formula should be straightforward. The only difference here is that there might be an I. All right, number 4. So number 4 and 5, graph the following using the leading coefficient test, finding the zeros of the polynomial, and the intermediate value theorem. Okay, so leading coefficient test, that should be the easy part. The degree of this, that's 4, right? That's the highest exponent, and this is even. Leading coefficient, it's the thing in front of x to the 4th, so it's 1, which is positive. So we get this general shape, which is going to be this top left-hand corner right there. Okay, so that's what our graph is going to look like. And then what we have to do is we have to find the zeros. Right, so general shape starts up top left and ends top left, or top right. Okay, then we have to find the zeros. And there's going to be one of each of these, right? So there's going to be one where you have to factor as normal, and then there's going to be one where you factor by grouping. So if we just factor x to the 4th minus 9x squared plus 14, we need factors of 14 that add up to negative 9, right? So that'd be x squared minus 7 and x squared minus 2. set each of those equal to 0, and solve. And we get plus or minus rad 7 and plus or minus 2. Right, so that's the second part, right? The first part is the leading coefficient test to get the general shape. The second part is to get the zeros, which is what we just did. And then the third part is to kind of test in between those zeros to get an actual picture of the graph. And for my sake, this is like 1.4, rad 7 is like 2.6. Okay, so if we graph this, okay, we graph our zeros. We get plus or minus 2.5-ish. These a little bit more spread apart. Okay, so rad 7, that's like right here. Rad 2, that's like right here. Negative rad 7, it's like negative 2.5, and then negative rad 2, it's like right here. Okay, so we plot those points, and then from here, we already know part of the graph. We know it's going up both sides because of our leading coefficient test. So we know it's coming up like this. Okay, we need to find out what's happening between each set of these zeros. So we need to test something in here, in between these two zeros, and then in between these two zeros. All right, so we need to test. So to the left, we can test negative 2. So we plug that into our original. So negative 2 to the 4th minus 9x. So minus 9 times negative 2 squared. And then plus 14. And what we're worried about here is the sign. Okay, so negative 2 to the 4th, that's positive 16. 2 squared, that's 4, times negative 9, that's negative 36. And then plus 14. 16 plus 14, that's 30. 30 minus 36, that's going to be a negative number. So our graph is going to come down and then back up to that 0. So we get something that looks like that. Okay. Then we do the same thing with green, so we can test something in between these two zeros. So we can try 0. So we get 0 to the 4th minus 9 times 0 plus 14. That just ends up being 0 minus 0 plus 14, which is positive. So it comes up. And then it comes back down to the 0. And then we test that spot in orange, so we test positive 2. And we're going to get the same answer here, but 2 to the 4th, that's 16 minus 36 plus 14. That's also going to give us a negative number. So our graph is going to come below the x-axis and then come back up to that 0. Okay, so that's all of the work I would expect, right? So the leading coefficient test up front, finding the zeros right here, plotting those zeros, and then testing in between each set. And those are the colors that I have. Okay, so there's a lot of steps there, but a lot of it's stuff we've already done. It's just putting it all together. Okay, so the second one, that's number 5. So there's going to be one where we're factoring just like we did on the left, and then there's going to be one where we have to factor by grouping. Okay, I'm going to do this just slightly. No, I'll do it in the same color. So we can group in different ways. I'm going to group these two together and these two together. Okay, so the greatest common factor in that first one is x squared, right? We can pull an x squared out of both of those terms, and we're left with x minus 5. The intermediate value theorem states that if you ever switch signs, you have to go through 0, right? So down here, right, this is a negative value. We cross 0, and then we have a positive value, right? So if we get a positive value between two zeros, every value between those two zeros is positive. So it has to come above the x-axis. Same thing with negative. If you get a negative between two zeros, all those values have to be 0. And then same over here. That's basically what it says. There's a lot more formal of a definition, but you're going to go over that in calculus. Okay, so recap. Greatest common factor between these two things is x squared. You take that out, you're left with x minus 5. Then I'm going to factor out a negative 1 from these right two. And we're going to be left with x minus 5. So the goal is to make these two things equal. That way you can take that out of both of them. Okay, so now we still have two terms. Right, we have this term on the left and this term on the right. Okay, the greatest common factor here is x minus 5. And when we take that out, we're left with x squared minus 1. And we know that this is equal to 0, right, because we're trying to find the zeros. Oh, I forgot to do the leading coefficient test. That's easy. Degree here is 3. That's odd. The leading coefficient is 1 again, which is positive. Okay, so that gives us the general shape. But back to this. So we set x minus 5 equal to 0, or x squared minus 1 is equal to 0. Okay, so this is easy. X is equal to 5. And then there's two ways to do this. You could either factor this or just add 1 over. So x squared is equal to 1. And you have to be careful here because x is equal to 1 and negative 1. So you have 3 zeros. You have this guy, and then these two, right? So whenever you take a square root, it's always going to be plus or minus. Then we have to graph it. Okay, so we plot those points. So we have 5, we have positive 1, and we have negative 1. So those are zeros, and our job is to fill in the rest. Okay, so we know from our end behavior, right, because this degree is odd with a positive leading coefficient, it's going to go down to the left and up to the right. Then we have to test in between each set of zeros. So we can test in between these two zeros, and then we test in between these two zeros. So if we test in between in red, we can just test 0. So we get 0 cubed minus 5 times 0 squared minus 0 plus 5. And when you do that, you're just left with that positive 5, which is positive, right? So our graph between those two zeros is going to come up above the x-axis. Do the same thing in green, so let's plug in something like 2. So we get 2 cubed minus 5 times 2 squared minus 2 plus 5. 2 cubed is 8. 4 times 5, that's minus 20. Minus 2 plus 5. So negative 22 plus 13, still negative. So that means our graph is going to come below the x-axis and then come back up to hit that 0. Okay, so that's our graph. Okay, so again, a lot of steps. It's all stuff we've done. We're just putting it all together. So take a second. Make sure that makes sense, and then I'll give you like 30 seconds or so to look at that. and then we'll move on to the next ones. Okay. So we'll move on. And this gets to the asymptote stuff. And then we're almost done. So there are a lot of rules for asymptotes. We still have to know them. All right. So I always start finding the vertical. I'll do vertical in red. So let's start with the directions, right? So find the vertical, find horizontal, and find slant asymptotes. Show all work. Okay. Vertical is really easy. It's just doing the same thing we've been doing for the last couple of questions, right? We're just finding zeros. So you always set your denominator equal to 0. So we set negative 2x squared plus 2x plus 4 is equal to 0. And we have to solve for x, either by factoring or by using the quadratic formula. Okay, so I noticed that there's a negative 2 in each of these. Okay, and then we can factor the inside of that parentheses. So factors of negative 2 that add up to negative 1. So just negative 2, positive 1. So you get this. And then we're just solving. So x minus 2 is equal to 0. X plus 1 is equal to 0. So x is 2. And x is negative 1. Okay, so those are vertical. Let's see if I can make this look good. X equals 2. Nope. Okay, well, that didn't work. Okay, so x equals 2, and x equals negative 1. Okay, then we need to check for horizontal. For horizontal, we have to compare the degrees of the numerator and denominator. So n, the degree in the numerator, right? The numerator is just 1, which means n, like that's the power of x, which in this case is just 0. M is the degree in the denominator. So it's the greatest exponent in the denominator, which in this case is 2. Right? N is less than m, which means that y is equal to 0 is our asymptote. Right? So there's those 3 cases. I had those at the very, very beginning. They're also in your notes, so take a look at those just to make sure you know them. But that gives us basically just the x-axis. That's our asymptote. Okay. So there is a vertical, there is a horizontal. If there is a horizontal, you don't need to check for a slant. And then our only job now is to test. Okay, so we need to test to the left. So we need to test right somewhere around here. We need to test in between the 2 red dotted lines, and then we need to test to the right. Okay, so let's test to the left first. So if we plug negative 2 in, we get 1 over negative 2 times negative 2 squared plus 2 times negative 2 plus 4. And all we're worried about is whether or not we're below or above that that y equals 0. Okay, so this is going to be 1 over negative 8 minus 4 plus 4, so that's a negative number. and that is below 0. Okay, so our graph is going to look kind of like that. We need to test between the two red dotted lines. So we get 1 over negative 2 times 0 squared minus 2 times 0 plus 4. That's just positive, right? Because those things cancel out, and we're left with 1/4, which is above 0. So our graph is going to look kind of like that. Okay, then we test to the right, so we can test 3. And when we do that, 3 squared, that's 9. So negative 18 minus 6 plus 4, that's clearly going to be negative, which is below 0. So our graph is going to look like this. Okay, and then that is everything, right? So we find the vertical asymptote, that's in red. We find the horizontal, that's in green. And then we test to the left and right of the vertical in blue, orange, and pink. I hope I'm still going. YouTube doesn't like me right now. That's unfortunate. All right. All right. Technical difficulties. This will seem weird when people are watching it back. Whatever. Stream just canceled out, so I'm just going to upload this later. So we did question 6, right? We found the vertical asymptote, so setting the denominator equal to 0. We tested we got the horizontal asymptote by comparing the degree of the numerator, n equals 0, and denominator, m equals 2. N is less than m clearly, so y is equal to 0. And then we tested to the left of both asymptotes, in between the asymptotes, and then to the right. So left is blue, middle is orange, and right is pink. Okay, so that's all of number 6. For number 7, we do the same thing. We test for vertical. So we set negative 2x plus 6 equals 0. And we just solve. So negative 2x is equal to negative 6. So x is equal to 3. Right, so that's our vertical. Easy. Okay, horizontal. We check the degree of the numerator, which is 0. The degree of the denominator is just 1. N is less than m still. So we have the same case, so y is equal to 0. Okay, so those are the 2 asymptotes. And then really all we need to do, because there's a horizontal, we just need to test to the left and to the right of that vertical. So let's test to the left. The left, we can test 0. So 1 over negative 2 times 0 plus 6. That's just going to be 1/6, which is above 0. So our graph is going to be up above, right around here. Okay, we do the same thing. We can test 3. We can do that in pink. So 1 over negative 2 times 3 plus 6 is equal to 1 over negative 6. Sorry, that should be a 4. Can't test the asymptote. So let's do 4. So negative 8 plus 6, that's 1 over negative 2, which is below 0. So our graph is going to look like this. All right, and then we're done. We've tested to the left and to the right, and we just go from there. So those are the easier asymptote questions. The harder and more involved one is the one involving the slant, which I will get to here in a second. But first, let's do the vertical. Luckily, this vertical is easy. Just set 3x plus 9 equals 0. So x is equal to negative 3. That's right there. And then we check for horizontal. Okay, n in this case is 2. That's the degree of the numerator. M in this case is 1. 2 is greater than 1, so there's no horizontal. Okay, but because there's no horizontal, we have to check for a slant. And the slant only happens when the degree of the numerator is exactly 1 greater than the degree of the denominator. So 2 is exactly 1 greater than 1. So there is a slant. In order to find that, we have to do long division. Okay, and I'm going to put a 1 in front of x, so this makes a little bit more sense. We need to ask ourselves how many times 3x goes into 1x squared. Right, so 3 times what is 1? 3 times 1/3 is 1. So we get 1/3 x, right? 1/3 x times 3x, that gives us 1x squared. 1/3 x times 9, that gives us 3x. And then we're subtracting. So 2x minus 3x, that's negative x. Bring down the negative 8, so negative 8. And then just rinse and repeat. So how many times does 3x go into negative x? That's just negative 1/3. And when we do that, really none of the rest matters. Once we get an equation of a line, we're done. So we need to graph that line, right? So our y-intercept is like negative 1/3. It's right about here. And then we go up 1 over 3. Up 1 over 3. And then that is our slant asymptote. Okay. Now this is a little bit harder because we have to check to the left and to the right, and we have to see if the value we get is above or below our slant. Right, so we'll do the first one in blue. So let's test to the left. Let's test negative 4. So we get negative 4 squared plus 2 times negative 4 minus 8 over 3 times negative 4 plus 9. That's going to give us 16 minus 8 minus 8, so that's 0, over negative 12 plus 9. It doesn't matter. It's negative 3, but that's still going to be 0. Okay, that's pretty clearly above, but what I would do just in case is check it with this equation. Okay, so we could check 1/3 times negative 4 minus 1/3 and just see if if our value here is below or above this value that we're trying to find right here. Okay, so negative 4/3 plus minus 1/3, that's negative 5/3. Okay, our negative 4 value, right, this is pretty clearly above negative 5/3. 0 is above negative 5/3. So our graph is going to be up here. Okay, that's not quite exact, but you get the point. Okay, then we test to the right. So let's test 0. So if we test 0, we get 0 squared plus 2 times 0 minus 8 all over 3 times 0 plus 9. So we just get 9, so negative 8/9. If we plug that into our line, right, we get 1/3 times 0 minus 1/3. So we get negative 8/9 and negative 1/3. Right, so that's from this guy up here, right? So we're checking to see if our slant is above or below this value here. So negative 8/9 is less than negative 1/3, so it's below. So our graph is going to be looking like that. Okay, and then once you do that, you're done. You test it to the left and to the right, and you have a slant. So that works. Okay, so check vertical, check horizontal. If there is no horizontal, check slant, find slant, and then test left, test right, which I know is simpler said than done, but that's the idea. Okay, then the last two questions are just simplifying. Okay, in order to simplify things with sums in the denominator, right? So 2 rad 5 plus 2, whenever you see stuff that looks like that, we're multiplying by a conjugate. So the conjugate of that denominator is 2 rad 5 minus 2, and then we have to do that over itself. Okay, so this is equal to 4 times 2 rad 5, that's 8 rad 5. And then negative 2 times 4, that's negative 8. Over 2 rad 5 times 2 rad 5, that's 4 times 5, which is 20, minus 4 rad 5, plus 4 rad 5, minus 4. So these cancel. So you're left with 8 rad 5 minus 8 over 20 minus 4, which is 16. And then once you get here, you're good to go. So if that seemed really fast, what I was doing is foiling, right? I have to foil the denominator. So 2 rad 5 times 2 rad 5, that gives me 4 times 5. Right, so just make sure people understand that. 2 rad 5 times 2 rad 5, that's 2 times 2, which is 4. And then rad 5 times rad 5, which is just 5, which is equal to 20. And then you continue to foil, right? And that's how we get all that. Okay. Second one, it's just slightly harder, but not really. We still have a difference on bottom, so what we have to do is we have to multiply by the conjugate, which is negative 2 plus 5i. And then we have to FOIL the top and bottom. So negative 2 times 4, that's 8. Negative 2 times negative I is plus I, or plus 2i. And then the same thing. So 5i times 4, that's plus 20i. And then plus 5i times negative I is negative 5i squared. Negative 2 times negative 2, that's 4. Negative 2 times negative 5i, that's plus 10i. Negative 2, or sorry, 5i times negative 2, that's negative 10i. And then 5i times negative 5i is minus 25i squared. And then we just have to simplify, right? So these two things cancel. I squared is always negative 1. And then we can add like terms together. Okay, so we get 8 plus 22i plus 5, right? So negative 5i squared is negative 5 times negative 1, which is positive 5. And then down bottom we get 4 and then plus 25 for the same reason. Negative 25 times negative 1 is positive 25. So then we get 13 plus 22i over 29. And then this is our answer. Okay. Normally I would take questions, but right now the stream is actually off and I'm just recording. So I'm going to stop here and then I'll upload this. I'll scroll through really quick. And then I'll stop it and then it'll be up for people to watch. So I'll upload this. This will be available for people to watch it. Hopefully in the next couple minutes for juniors. But for seniors, this will be available up until the test, and then after that. But probably won't watch it after it. So if you're watching, thank you, and good luck.